Hello, and thank you all for tuning in to my second update on my data science project. This update is on my data collection, cleaning, and all of the pre-processing steps. So the source of my data is PhysioNet. I have gone ahead and included a link to where you can find it. This is a restricted data set. However, it is open to the public and anybody can gain access. The way you do that is to become a credentialed user at the site. You do this by giving them your university email and the information of someone above you, like the instructor of a course or whoever's overseeing your project. Once that all goes through, you complete some training for them, and it just explains that this is patient information and you need to handle it ethically. And lastly, you have to sign the data user agreement, which goes hand in hand with the training. You're just acknowledging that yes, this is patient information. You will not attempt to identify them. You will not share this data with just anybody, and any insights you gain from it won't harm the people that they get information from. The reason they make you jump through so many hoops is this is real patient data on over 200,000 patients from a Boston hospital. All right, my ETL process, or the extraction, transformation, and load. So for data extraction, it was pretty simple. After you complete all the necessary steps I listed in the previous slide, you are given access and you can just download all the files. It does come in one large zip folder, around 9 gigabytes, um, but it contains 22 CSV files. I list here, I only kept the relevant ones. The reason being, there is so much patient information that you are given, and along with all of the patients, all of their visits, all of the tests ordered and their results, their medication, the dosages, and this will all be talked about later in the cleaning step, but we're given a lot of information. The relevant files for the load process, I just read directly into R. There was no extra cleaning step needed at this point. So, as I mentioned before, after loading it up into R, there's a little bit of fine tuning that was required before it is ready for analysis or using any sort of statistical method of prediction. So we have the initial data profiling, just looking at the data structure and completeness. It was pretty straightforward on my end. Every CSV file has a bunch of different columns with headers. Took a little bit of time for me to identify what all of them meant. Some of them are abbreviations, but looking online, they were all very commonly used. And all of the CSV titles were extremely helpful and detailed in describing what is contained within it. I couldn't find any missing data in my data set. I don't know if it is just because hospitals keep incredibly meticulous records or PhysioNet regularly updating it and fixing any problems they can find. Likewise, I didn't have any issues with formatting and consistency. Everything was very straightforward. It's either an integer or a character. And again, my job was made easy when it came to outlier detection. I didn't find any samples that jumped out. Specifically, I was looking at, okay, are there going to be patients that were admitted dozens of times? Those I would ignore. However, that was not the case. Variable reduction is really my biggest feat here. As I mentioned, there are 22 CSV files. Every single one of them has a dozen columns detailing something that's going on with the patient. Uh, so uploading the necessary CSV files and then gutting about 60% of all of the columns made my computer heat up so hot it melted a hole in my desktop. Lastly, scaling and normalization, I didn't have any problems with that or have the necessity for this process. Some additional pre-processing steps that I took, encoding categorical data, it was pretty straightforward. R doesn't seem to be having a hard time conceptualizing this. I would handling imbalanced classes. In this data set, I so far have not run into anything that seems imbalanced. That might change moving forward, but for the time being, we are okay. And data set partitioning with my data splitting, uh, I so far have only written code to make myself a training set. It seems to work pretty well. I won't know until later on when I start testing and running actual models how effective it is. So, wrapping everything from my previous slides together, we get my data integration. I'm using multiple data sets to make my working file, such as previously mentioned admissions, patient information, medications, lab results, and diagnosis. All of that stuff gets merged together, and I was kicking out variables that I didn't think were relevant or wouldn't yield usable results in terms of predicting readmission. And with that, I think I have a data set that will work really well for me. I have as much information as I can possibly have in a usable format, and I also have the categorical were they readmitted, yes or no, and I should be able to do some really good modeling with it. And so, after all of that work over the past 2 weeks, I end up with a data file that I can use for my predictive modeling. It definitely wasn't fun sifting through the mountain and gigabytes of data files, some that were so large my computer refused to open them in Excel. But for the time being, it seems like R is accepting what I have and is churning out usable information. I hope that in the coming weeks it proves to be useful and I do not have to go back and redo or readdress any of my previous steps. However, I do understand that if problems should arise, that might be a great place to start looking. Thank you for your time.